In this video, we are going to look at the difference between longitudinal and transverse waves, and we're going to evaluate the difference in terms of these two things. So as you watch the videos, I want you to think about the direction of energy transfer and the direction of the oscillations of particles. So here's an example. Let's say the source of the wave is the wrench, and I'm wiggling the wrench. So I wiggle up and then down. Oops. Let's try that again. Up and then down, and a wave is sent along. So there is energy being transferred, passed from one particle to the next, to the next, to the next. The energy being transferred is oscillatory energy, or the energy of oscillations. So it's a mix of kinetic and potential. Oscillatory energy is being transferred along. And which way is the energy being transferred? It's going to the right. The direction of energy transfer is to the right. What about particles? Which way are particles moving? Are they moving to the right as well? Well, we look and we see, no. Each green little ball here, each green particle, is moving up and down as the wave goes to the right. So let's show that with a continuous wave. So this green particle here goes up and down and up and down, but the crests are moving to the right. So as a crest comes, it travels over to the right. Right? Here's a crest, follow my mouse, it goes to the right. But the particles go up, down. This kind of wave, where the particles oscillate perpendicular to the direction of energy transfer, is called a transverse wave. So a transverse is where let's try this one last time. Particles oscillate perpendicular to the direction of energy transfer. That's a transverse wave, like this. On the other hand, we might have waves that are different from the wave on the string. What we're looking at now is called a longitudinal wave, or you might sometimes call it a compression wave or a pressure wave. But the term that IB physics uses is longitudinal wave. A longitudinal wave is one where the particles oscillate parallel to the direction of energy transfer. So which way is the wave going? Which way is the energy being transferred? Watch a single compression here, and you see it moves to the right across the screen. So I'm moving with my mouse, I'm tracking with my mouse one of the compressions. Oops, I got ahead. And the compression continues traveling forward. But a single particle, if we just pick a single particle like this red one here, and watch it, we see it only oscillates left and right about some equilibrium position. So the particle is oscillating left-right. That's parallel to the rightward motion of the wave, parallel to the direction of energy transfer. So this is called a longitudinal wave. Longitudinal is where particles oscillate parallel to the, what happened? Parallel to the direction of energy transfer. There are a couple other terms to know. When we look at a wave on a string, a point on the wave where the displacement is maximum is called a crest, and a point on the wave, right here is a point, where you have a minimum displacement, is called a trough. So the crests and troughs move forward for a traveling wave like this. Here's a crest rather. The crest is moving forward, the crest is moving forward, the crest moves forward. And likewise for the troughs move forward as well. Troughs are positions of minimum displacement on transverse wave, crests are maximum. On the other hand, We don't have crests and troughs on a longitudinal wave. What we have are compressions, which are really, really dense regions where particles are all pushed together, and rarefactions, which are not so dense regions where particles are spread out. So between two compressions, we have a rarefaction, which is also could be called an expansion. So compressions are points where displacement is where pressure is at a maximum. Troughs are where pressure is at a minimum because there are a few particles bouncing around at the troughs. So let's summarize. Make this a little bigger. Whoops. Transverse waves. We have crests, positions of max displacement. We have troughs, positions of minimum displacement. On the other hand, for longitudinal waves, we have compressions, positions of max pressure, and rarefactions, positions on the wave of minimum pressure on the wave. And we know that for these traveling waves we've seen, for traveling waves, which is all we've seen so far, the crests, troughs, compressions, and rarefactions move forward through the medium. They move forward through the medium.